right, let's welcome everyone in algebra back to day 5, 11.6. We've been doing 11.6 for a little bit because 11.6 was simplifying radicals or simplifying square roots, which we took a quiz on, and also rationalizing the denominator, which you did yesterday. So today we are going to do problems where we're going to rationalize the denominator, but we're not done just yet. So let's do a few examples together today. So let's just start with example 1. The original problem, I think I'm going to write this in dark green so that you know it's the original, is 5 divided by the square root of 10. So from what we looked at yesterday, you want to rationalize the denominator. You want to get rid of that square root of 10. The best way of doing that is multiplying it by the square root of 10, because the square root of 10 times the square root of 10 is square root of 100, which is 10. Whatever you do to the denominator, you also must do to the numerator, which is why you'll end up there. And at this point, you should notice that, hey, we're not done yet. Did we rationalize the denominator? Technically, but that's like, you're not finished because we want our solution to be simplified. When you see a fraction that can be simplified, like 5 goes into 5 once, 5 goes into 10 twice, and then you want your actual answer to be simplified. You don't ever have to write that 1 as a coefficient. You technically could. And is the square root of 10 simplified? Is there a perfect square? Our perfect squares look like this. Our perfect squares look like 4, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8. 9 times 9, 10 times 10. I'm going to keep those up there. Is there a perfect square that goes into 10? Can I simplify that square root? Nope. So therefore, I know that that is my final answer. Let's look at another problem. They're going to get increasingly more difficult. Maybe difficulty is the wrong word, just more steps. More things that you'll need to simplify. Steps you've done before, but just a whole bunch at once. So, again, I'm going to try and stay consistent with these colors here. 6 divided by the square root of 12. I prefer to do this in a very specific order. If you go home and do this with a older sibling or a parent, they might do this one differently, but this is how I prefer to do it. I always rationalize the denominator first. I want to get that radical out of the denominator, and I can do that by multiplying both sides by, or the top and the bottom by, the square root of 12. And at this point, you might notice that, hey, that square root of 12 was not simplified because 4 goes into 12. So this one, there's lots going on. But this is the steps I prefer to do it in. I prefer to get the square root out of the denominator. Check. Can I simplify any fractions? Yeah, I can. And you might actually have to do this later, but that's totally fine. Oh, awesome. Okay. Now am I done? Because I asked you up here, we were done up here, but we are not. Because the square root of 12, like I could have asked you on the test or on the quiz you just took, 4 goes into 12. So we're actually going to simplify this. The square root of 12 is the square root of 4 and the square root of 3, right? And we pick 4, we pick a perfect square, because the square root of 4 is 2. And so the square root of 12 actually turns into 2 roots of 3 divided by 2. That we simplified this. All of that work, all of this right here, I guess I could cover all of that up. That's a whole problem from our last section of 11.6, so you took the quiz on a few days ago. But now we're just adding more to it. We're adding all this stuff is common knowledge to you probably at this point, but we're just making it all at once, which is why it's a little daunting. Okay, am I done yet? Nope, I am not. Because 2 divided by 2 is 1. Could you write it like this? Yes, but this is the most appropriate answer. You wouldn't have to put the numerator or the coefficient of 1. This is a 3-step process. 1. Rationalize denominator. 2. Simplify fractions. 3. simplify radicals. And in this case, we actually had to simplify the fraction again. So I'm just writing these out. If you want to write them out in your notes, if you're like, okay, she wrote them down, moving on with my life, that's totally fine. But they're there for you if you need them. So let's look at another example here. Let's try this one. The square root of 3 divided by 2 times the square root of 6. This one looks different because there's numbers in the denominator, there's radicals in the numerator, but everything stays exactly the same. So let's see what this all looks like. I want to get rid of the square root on the bottom, so what do? I multiply the bottom by that square root. The 2, I didn't touch. The 2 just stays there. Bring over the 2. Awesome. What's the square root of 6 times the square root of 6? 6. Yep, so that's 2 times 6. And then the square root of 3 times the square root of 6, I'm multiplying those two things together, and I can multiply those to be the square root of 18. Okay. So I multiplied both the top and the bottom by the square root of 6. I move over here. Am I done yet? No, obviously. There's like multiplication going on. There's a lot going on. So let's just quickly finish up that denominator down here. Okay. Am I done? There's no fraction or like there's no like numbers that I can cross out there. But the square root of 18 can be simplified. What perfect square goes into the square root of 18? Does 4 go into 18? No. Does 9 go into 18? Yes. So 9 and 2 are the ones you're going to pick. So the square root of 18 is the square root of 9 and the square root of 2. 12 doesn't change. It just keeps moving over. What is the square root of 9? The square root of 9 is 3. Am I done yet? No, I simplified the radical and I still have one more fraction that I need to simplify there. That 3 and 12 can be simplified to 1 and 4. Sorry. And so in this case, 1 roots of 2, you could write that one if you wanted to, and that turns into a 4. There's no fraction I can simplify. The radical is simplified, so I am all done there. I'm going to try another example. If you want to stop the video right here and move on and try a different problem on your own, you totally can. But I'm going to do one more with you guys right now. 6 square root of 10 over square root of 2. Okay, I like to follow my steps. Get rid of that radical because that's what we came here to do. The rest of it is just extra. Square root of 10 times the square root of 2 is the square root of 20. Square root of 2 times the square root of 2 is 4. We radicalized the denominator, but it's just not simplified. You're just not done with the problem. Can I simplify that fraction? Yes. Can I simplify the radical? Yes. So you can do whatever you want to do right now. You can simplify the fraction or you can simplify the radical. It does not matter. I'm going to simplify the fraction. So which one? 2 goes into 6 3 times. 2 goes into 4 twice. 3 roots of 20 over 2. Okay. Am I done yet? No, I'm not. I got the radical done. Like it's not in the denominator. I simplified the fraction, but I need to simplify the radical too. So what perfect square goes into 20? 4 does, 9 doesn't, 16 doesn't. So 4 is it. Because if I couldn't plug in anything, I'd be done. But 4 goes into it. So 3, the square root of 20 turns into the square root of 4 and the square root of 5. And what is the square root of 4? The square root of 4 is technically 2. So the square root of 20 turns into 2 roots of 5 all over 2. At this point, there's a lot of things, like you could do a whole bunch of different steps. You could do it in different orders, so I'm going to do it in one specific order. If you're jumping ahead, that's totally fine. 3 times 2, so now I'm going to simplify. 3 times 2 is 6. Divided by 2. Yes, my radical is simplified. There's no radicals in the denominator. I am not done yet, though. 6 and 2 can be simplified to 3 over 1. And in this case, we don't have to write the denominator. We would be done there. You could put it over 1, but that wouldn't be mathematically necessary.